Dart School presents multiplying fractions. If we have a set of fractions that need to be multiplied together, the rule is multiply the numerators together and divide all of that with the product of the denominators. And then when you get this new fraction, simplify it to its lowest term. However, I would recommend that before you go on to multiply the numerators together and multiply the denominators together, see if you could reduce any factor from the numerator with any factor from the denominator. So that brings the numbers down and the multiplication becomes easier. Let me show you an example. Let's say you want to multiply the fractions 3/8 and 32 over 33. Now if you want to follow this rule, you would probably go on to multiply 3 with 32 and 8 with 33. They give you some big numbers. 3 times 32 is 96. So we have a 96 on the top, and 8 times 33 is 264. Now imagine reducing this fraction. That takes time, right? The better approach is to cross off this 8 and this 32, meaning you can divide the 8 with 8 and the 32 with 8. You can multiply or divide any factor from the numerator and any factor from the denominator with the same number. So you can divide this with 8 and this with 8. And the reason you want to do that is because 8 can go into 32. The idea is to divide them with their greatest common factors. And similarly, you want to divide 3 with 3 and 33 with 3. Now look how easy this becomes. 3 divided by 3 is 1, 8 divided by 8 is 1, times 32 divided by 8 is 4, and 33 divided by 3 is 11. That cannot be simplified any further, so we could just write this as 1 times 4 over 1 times 11, which is 4 11ths. Let's do another one. Let's have 2/3 times 7/10 times 9/14. Once again, we are going to look for common factors between numerators and denominators. Hey, we see a 2 here and a 10 here. So we can divide the 2 with the 2 and the 10 with the 2. That's allowed. Similarly, we see a 3 here and a 9 here. Divide them with 3. 3 divided by 3, 9 divided by 3. And finally, 7 and 14. Divide with 7. You know what I mean, right? So we have a 1 here. 2 divided by 2 is 1. 3 divided by 3 is 1. 1 over 1 times 7 divided by 7 is 1. 10 divided by 2 is 5. Times 9 divided by 3 is 3. And 14 divided by 7 is 2. So finally we have a 1 times 1 times 3 over 1 times 5 times 2. As easy as a pie. 3 over 10. And I encourage you to compare this method with the other method in which you simply multiply the numerators out, 2 times 7 times 9, and multiply the denominators out, 3 times 10 times 14, and then go on to simplify that big fraction. One final word from my side, in case you're still wondering, how could we reduce the numerator of one fraction with the denominator of another fraction, and do that several times? Well, the answer lies in the fact that at the end of the day, the numerator is 2 times 7 times 9 over 3 times 10 times 14, and because the order doesn't matter in multiplication, we call it the commutative property of multiplication. You can multiply numbers in any order. Therefore, this could have been rewritten as 9 times 2 times 7 over 3 times 10 times 14. They're the same things. Now essentially you're reducing 9/3 as a fraction, dividing them with 3. 2/10 as another fraction, dividing them with 2. And 7/14 as a third fraction, dividing them with 7, the numerator and the denominator. And this rearranging is often done mentally. We don't write that down. We just cross off a numerator and a denominator. Doesn't have to be right below it.